Most engineering teams don't fail because they can't build. They fail because they don't know what success actually looks like. You can have a clean code, solid architecture, on-time delivery, and still build something that doesn't matter. Because no one clearly answered this question. How will we know if we solved the problem? Once you have framed the problem, this is the next level of engineering maturity. Not just building correctly, but defining success correctly. Because success criteria are not just checkboxes, they are a compass. They guide decisions, shape priorities, and prevent drift. And without that clarity, teams can do impressive work and still miss the mark. So what does success actually look like? Not in terms of what we build, but in terms of what it changes. Define success in terms of real-world impact, not completed tasks. Developing a feature is an output. Improving user experience, reducing errors, increasing reliability, or saving cost, those are outcomes. When success is framed as outcomes, decisions become clearer. Priorities become easier to defend. Work aligns with value, not activity. Here is an example. A team might say their goal is to launch a new search feature. That's an output, and it cannot be the measure of success. A better definition would be reduce the time users take to find what they need by 30%. Increase successful searches by 50%. Lower support tickets caused by search failures. Now, success is tied to whether the feature actually improves user experience. Without clarity on outcomes, teams risk building something that is good but not effective. Even after you define success as outcomes, there is a second trap. If you can't measure it, you can't use it. Defining success is not enough. It must be measurable. Vague goals cause vague outcomes. Improve performance, enhance user experience, make the system more scalable. These sound meaningful, but without numbers, they don't guide decisions. What does improvement mean? By how much? By when? And for whom? A clearer definition looks like this. 95% of users experience a response in under 200 milliseconds. Support up to 20,000 concurrent users. Keep failures below 0.1%. If success cannot be measured, it cannot be evaluated. And if it cannot be evaluated, it cannot guide decisions. Examples. A payments team was asked to improve checkout performance. They made small optimizations for weeks. Every change felt productive. But there was no way to tell if they were actually succeeding. Finally, they defined a clear success criteria. 99% of requests under 30 milliseconds. Handle 5,000 concurrent checkouts. Failure rate below 0.5%. Stable under 2x projected load. This changed everything. It exposed architectural gaps. Their synchronous flow was not able to meet the target. So they redesigned using an asynchronous one. They introduced load tests, failure scenarios, and performance thresholds. And most importantly, it revealed something uncomfortable. Until success was measurable, their design decisions were largely random, based on preference, not outcome. Once success became measurable, decisions became more thought through. And that elevated both the system and their thinking. There is another dimension of clarity most teams miss. It's not just about what you build, it's about what you refuse to build. Clarity isn't just knowing what you are building, it's also knowing what you are not building. Knowing what problems you are not going to solve prevents over-engineering, reduces hidden expectations, protects timelines and focus, avoids accidental scope change. Saying this system will not handle more than 10,000 requests per second is often more powerful than vague promises of scale. Choose your boundaries consciously. Don't try to solve everything. Here is an example. A team building a reporting dashboard starts getting requests for real-time analytics and predictive insights. Instead of expanding scope, they set a boundary. This system will provide daily summary reports. It will not support real-time analytics or forecasting. As a result, the software stays simpler and more reliable. Its performance remains predictable. The timelines stay realistic, and stakeholders know what to expect. Another team later built a separate analytics system. Having boundaries did not limit their impact. They protected focus and preserved quality. Even after all of this, there is one final level of maturity. Most teams stop at solving the problems, but strong teams go beyond it. Most requirements are one-dimensional. They focus only on the core problem. If you define success only within that boundary, you may technically succeed, but won't create a lasting impact. Success must go beyond functional correctness. Here is an example. The problem: build a configurable pricing engine. A narrow success definition would be users can create rules. Prices are calculated correctly. Performance targets are met. Delivery is on time. But mature definitions go further. Success also means a user takes less than 3 minutes to add a rule. The UI is intuitive without long training. A support engineer understands the system in 2 days. Debugging takes less than 30 minutes. A new developer can take over in a week. Notice the shift. We moved from does it work to is it usable? Is it understandable? Is it diagnosable? Is it maintainable? Is it sustainable? These are not secondary concerns. They are part of success. Defining success only within the problem statement rewards completion, not quality. So ask, beyond solving the problem, what must be true for this to become a good outcome for everyone involved? That question separates delivery from engineering. If you step back, everything we discussed comes down to one shift: from activity to intent. When success is defined by outcomes, engineering decisions become meaningful. Priorities align with value. Trade-offs become clearer. You stop asking what should we build and start asking what must we do for this to be successful. Because in the end, effort does not create impact. Clarity does. Defining success and defining boundaries is what turns effort into meaningful progress. And this is just one step in developing engineering judgment. If you would like to see the full progression from execution to engineering authority, you can explore the complete engineering judgment framework at paragchitnis.com.